All right, let's jump right in. If you come from the world of relational databases, the whole object-oriented programming thing can feel, well, like a different planet. One world is all about data at rest, perfectly structured. The other is about data in motion, all about behaviors and interactions. So in this explainer, we're going to build the bridge that connects those two worlds.
First, we'll look at how these two different systems even manage to coexist. Then we'll break down the basic building blocks of software, program modules. After that, we'll get into what object-oriented classes really are, tackle the huge question of how objects get saved permanently, and finally, we'll see how these objects actually talk to each other.
So let's kick things off with the big question. On one hand, you've got your data-centric databases. Their whole job is stable, reliable, non-redundant storage. On the other hand, you have behavior-centric code, which is all about what you can do with the data. So how on earth do these two, with their totally different priorities, work together in one system?
Well, the cool thing is, there's a pretty direct translation guide between them. Think about it. What you know as a table definition in your database, that's basically a class implementation in code. A single row of data, that's what programmers call an object instance. And a column is just an attribute. The words are different, for sure, but the underlying ideas are actually way more similar than you'd think. Okay, to build on that, we really need to get a handle on the pieces from the programming side. And that brings us to maybe the most basic concept of all, the program module. So what is it, and how do all these different modules come together to make a whole piece of software? At its core, a program module is just a self-contained chunk of code that's designed to do one specific job really well. You can think of it like a specialized wrench in a big toolbox. It could be something you recognize, like a stored procedure, or it could be a class. But the point is, it's the fundamental unit we use to build software.
But of course, these modules don't just sit there in isolation. They have to connect. And they do that in three main ways. First, there's composition, where one module is literally a part of another one. Then you've got dependency, where one module needs another one to even do its job. And finally, there's communication, where modules are actively sending messages back and forth to get things done.
So let's follow that thread. We just mentioned a class implementation can be a type of module. This is right at the heart of object-oriented design. But what exactly is a class? Is it just some fancy new name for a database table? Well, it's a little more interesting than that.
And this right here is probably the most important distinction to make. A business idea, like customer, is just that. It's a concept. The class implementation, though, is the actual physical piece of code, the computer artifact, that describes that concept. It's the blueprint. And from that one single blueprint, a program can stamp out thousands of individual customer objects.
And not all classes are created equal. A business class is the one we usually think of. It represents a real-world thing, like a person or a contract. But you also have architectural classes that do technical jobs, like managing a database transaction. Then there are application classes, which are super specific to one program. And finally, foundation classes are those reusable basic bits of code that handle things like dates or numbers. Okay, this next part, this is where our two worlds really collide head-on. An object, which gets created from a class blueprint, only exists in a program's temporary memory. The second you close that app, poof, it's gone. For anyone with a database background, this should be setting off alarm bells. It raises the most critical question: how do you save it?
Let's just put that question right out there, because this is the key to the whole thing. How does a fleeting, temporary object that exists only while a program is running become solid, permanent data inside a database table?
The answer, the magic word, is persistence. A persistent object is simply an object that gets to live on even after the program that made it shuts down. And the most common way to do this by far is to take all the data inside that object and store it somewhere permanent, like, you guessed it, a relational database.
Let's make this totally concrete. So imagine our program creates a person object. Right now, it exists purely in the computer's RAM. It's an instance of the person class, and it has attributes, a name, an ID, a status, and each one has a value. But again, if the power goes out, all of this vanishes. So to make it persistent, the program does this mapping. The object's attributes become the table's columns. The values inside the object become the values in a new row. And just like that, the temporary in-memory object now has a permanent physical home in the database. So we figured out how to store the data, which is great, but we're still missing half the picture.
Remember, the whole point of objects is that they don't just hold data, they have behaviors. They actually do stuff. So how do they do it? And maybe more importantly, how do they work with each other?
It really starts with understanding this difference between an operation and a method. An operation is the what. It's a service the object promises it can do, like calculate a total or update a status. A method is the how. It's the actual block of code that gets executed when you ask for that operation. So one's the promise, and the other is the action.
And the way these things get triggered is actually beautiful in its simplicity. It's all done through messages. One object's operation will send a message to another object. That message tells the second object which of its operations to run. And the whole complex dance of a modern application is really just a huge series of these messages being passed around.
And there you have it. That's our bridge between the world of relational databases and object-oriented design. If you found this useful for connecting those dots, do us a favor and hit that like button. Share it with someone who might need it, and of course, subscribe for more clear, concise content just like this.
We'll leave you with one last thing to chew on. We've seen how data structure and program behavior are really just two sides of the same coin. But as we build the complex systems of tomorrow, which side should be in the driver's seat? Should we start with the stable, long-lasting structure of the data, or with the dynamic, ever-changing behaviors of the program? It's a question with no easy answer.